Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the part number C, that is synthesis of disaccharide, trisaccharide, polysaccharide. How do we define disaccharide, trisaccharide or the polysaccharide? So what are the commonly observed disaccharide and how it is made up of, or after the hydrolysis what type of the sugar units they produce? So that type of the discussion we have discussed. In that we also discuss the stereoselective synthesis of beta monoxide. How do you define stereoselective, or what do you mean by the beta monoxides? Beta monoxides, beta means, as we know that when the compounds carbohydrate, in the carbohydrate chemistry, when the compounds are formed, the most stable conformation is most stable conformation will be the chair conformation, and that chair conformation always obtain during the synthesis of different derivatives. So in that, yesterday we have seen stereoselective synthesis of beta monoxide, how that beta monoxides are obtained starting from that alpha D monoxide. In scheme number 1 we have discussed in details. So today we are going to discuss the remaining part of that one, chemical methods. Now we are going to learn as a chemical methods. Chemical methods. In the chemical method, it include glycosylation with manosyl donor. Glycosylation with manosyl donors. What does it mean? And manosylation using insoluble promoters. By using this term we are going to discuss this point today. Let's see the introduction of this. Silver cations on the surface of insoluble catalyst anchor manosyl bromides from the alpha side. As a consequence, highly reactive alcohol can attack the anomeric center from the beta side in an SN2 type reaction, thus leading to beta monoxide linkages. The first application of this principle was reported by Perlin is a scientist name, in 1961, who condensed the cyclic carbonate protected manosyl bromide 2 and the reactive glycone under a silver oxide activation to afford the first synthetic disaccharide 4 that contain a beta mannopyranoside linkage, which is represented in scheme number 2. Let's see what is that. Let us see here. This is a compound where the bromide here present at below the plane in this particular case, suppose, and now this is a carbonated O, C double bond O, this one. Now at this junction or at this corner, that is a protected acetyl group, and then here is a CH2O acetyl group. This is a structure number 2. It will be treated with the compound, this compound, the here O acetyl group at anomeric carbon atom protected, then here also as a O acetyl group, and here once again acetyl group, and here also as a protected acetyl group. And now here for desired product we kept this group hydroxyl, primary hydroxyl group is a free, so that it will be treated with silver Ag2O, silver oxide, I2 act as an catalyst over here. This is the first reagent, and the second reagent added will be barium hydroxide. Barium hydroxide is a weak base here to convert the process of hydroxylation. And now this is a, now remember here, this is a one of the sugar unit, this is another sugar unit, combined together two single monosaccharide. This is also as a monosaccharide, it is also as a monosaccharide. When they combine together, you are going to get as a two sugar unit, means a disaccharide here you are going to get, and the reaction which this is can act as a nucleophile, and here leaving group is a here attacking like this, and there is a departure of leaving group, and this kind of the reaction is occur as a SN2 type of the reaction. And as we know, the characteristic or the feature of that SN2 type, it is a concerted reaction. So let us see over here. So what type of the product do you get over here? Let us see. This part we can show as it is here, but when it is attacking over here, here would be as a this oxygen atom and then CH2, and you can other part you can write as it is here like this, and then these all the protected group due to the presence of barium hydroxide get deprotected, and we will get here OH, here also as a OH. Now sorry, here is a here CH2 and this one, and here hydroxyl group is OH over here. Please make the correction over here. This the joining of that link is over here, and now here this is a hydroxyl group, and here also as a hydroxyl group, this OAcetyl hydroxyl group, and here also becomes as a CH2OH, and this is nothing but as a structure number 4, and this structure number 4 we can call it as a disaccharide. It is a disaccharide. It is a disaccharide compound, means two sugar unit combined together, that is a 1,6 beta glycosidic linkage. Here is a 1, 2, 3, 4, 5 and 6. This one 1, 2, 3, 4, 5 and 6. Look at one position and 6 position. Sorry, here is a not CH2. Here directly you can, this CH2 nothing but as a this, make the correction. This CH2 is, it means that 1,6 beta glycosidic linkage is found in this structure, and this is the scheme number, I think CH scheme number second is represented in this way. The main noteworthy point you should remember here, this is one of the starting material. One act as an electrophile, one act as an nucleophile. One is a, here this one you can call it as a donor, it can act as an acceptor. So the nucleophile attack always attacking from the this type of the reaction, similar to as a SN2 type of the reaction. SN2 means substitution nucleophilic bimolecular reaction, and we know that the characteristic of SN2 reaction, it is a concerted reaction. Concerted means what? The breaking of bond and formation of the bond taking place simultaneously. That type of the reaction are known as concerted reaction. Another speciality of this reaction, it is a bimolecular reaction. 2 stand for bimolecular reaction, means here the 2 moles is participating, means the rate of the reaction depend upon the concentration of the substrate as well as the reagent used here. 2 moles participating, and therefore it is a bimolecular reaction. And main characteristic of that SN2 reaction, when you start the if there is a optically active substrate, and as we know that most of the carbohydrates are optically active in nature. Optically active means they can rotate the plane of polarization either left hand side or the right hand side. That type of the compound is known as a optically active compound. It is one of the important physical property of the organic compound, or we can say here is a carbohydrate chemistry has, and the instrument used to detect the optical rotation is a polarimeter. And the resulting compound, if your substrate has R configuration, and whenever you get the product must have, or product must possess the S configuration. So that is the main characteristic of SN2 type of the reaction. Whenever product is formed, that product always is a inversion product, means because the nucleophile is attacking from the back side, and therefore the suppose and that's why we are getting as a this type of the products over there. So because of the chain imposed on the pyranose ring by the fused carbonate moiety, look at here, there is a carbonate moiety in 2, the formation of the planar carbonium ion from it is disfavored on SN2 type, anomeric displacement predominates when strongly nucleophilic primary and secondary alcohols are used as the glycones. Condensation with moderate nucleophile proceed in lower yield and with reduced beta selectivity. Interestingly, Ag2O assisted reaction of the carbonate 2 with weak nucleophiles gives exclusively alpha monocytes. The use of silver carbonate as the promoter has been successful for beta selective condensation between the O-benzylated donor 5 and the reactive non-carbonate primary alcohol 6 to give 7, which is represented in scheme number 3. Let us see here. Let me clean the board first and then we will represent the another scheme. From that, how we can get as a beta monocyte that we are discussing. So let us see here the starting material. This one O, there is a chlorine atom, and rest of the group we can show over here OBN, then OBN. Now here is a OBN, and this structure is nothing but as a structure number 5, and that structure number 5 will be treated with this reagent HO. Then you will see over here C double bond O, OBN, and this is a structure number 6. When the structure number 5 and 6 addition takes place together, or there is a reaction takes place between these two molecules or between these two compounds, under the reagent Ag2CO3, that is a silver carbonate, in presence of this one DCM CH2Cl2, that is a dichloromethane, yield is obtained near about 64%, and once again the reaction takes place according to the SN2 type. Look at here, this nucleophile attacking from the back side, there is a departure of chlorine, and you will be getting the product over here, this one. Now this is going to acquire at this position, then C double bond O, BN. This is a structure number 7, and rest of the group, they are present at equatorial position, and we can show as it is here O, BN. Now here there is something that is a monocyte, so we have to show over here is a OBN here, and that remains as it is OBN. That is a benzylic group protection. There are some common protecting groups used in the carbohydrate chemistry. One is CpHCH2O minus, and introduced under sodium hydride as a base in presence of benzyl bromide or benzyl chloride and removed under the palladium charcoal. So that is what we can call it as a H2 hydrogen, molecular hydrogen in presence of the palladium charcoal as a catalyst. And another one is a CS3COO minus acetate group. It is introduced under basic condition pyridine, and the reagent is used generally acetic anhydride, and this for the deep protection purpose or removal of this group, catalytic amount of sodium methoxide in presence of methanol is used for the deep protection of this group. Another one, ester group, C double bond O CS3 group, also introduced under acidic condition H plus in presence of methanol, and it will be removed and very dilute sodium hydroxide. These are the things over there. Now if you observe this reaction here, this reaction also takes place according to as a SN2 type reaction, and as we know that the characteristic reaction of that SN2 reaction, it is now here the leaving group present at axial position in this compound, and whenever the nucleophile incoming group is coming which is lying at a beta position, so from backside exactly this one is below the plane and this group is present at above the plane, means this chlorine group present at alpha side and this must be present on the beta side. Beta side means above the plane, alpha side means below the plane. So that is the product which we have got over here. High yield have been achieved with the Paulsen silver silicate activator precipitated on aluminum oxide that can also act as a water scavenger. A threshold level of acceptor reactivity is necessary for satisfactory beta stereoselectivity, whereas coupling of manosyl bromide with the anhydrous derivative 9 proceed in an excellent yield and high beta selectivity to afford manosylation of the less nucleophilic disaccharide with the same donor affords the trisaccharide 12 as alpha beta is a 50-50%, means 1:1 anomeric mixture, and which is shown in the scheme number. This is a scheme number 3. This one is a scheme number 3. And now we will see the next scheme, and which is here I am going to represent that scheme over here. Before that, let me clean the board so that you can see the scheme number, next scheme number 4 in nice way or in a clean way. Now let us see here that this is a structure number. Now here I am showing O, not O. Here the structure is this one, O, this one. Now here also has a, this is a glycosidic bromide, this one, and now here this group is protected by benzyl. Here you can write O all, then O acetyl, and here is a O all. O all means these are the protected group. Now this is the structure number 8. Remember, now it will be treated with this structure, the structure which I am going to show over here. See here, this is a structure where the other here is the OBN, that is a protected hydroxyl group. This hydroxyl group kept as a free so that reaction can occur at this particular, and here is a azide which is a good living group attached over here, and this structure is nothing but as a structure number 9. When these two structure and here used as a Ag silver silicate as an promoter over here, and this reaction carried out in presence of CH2Cl2 DCM dichloromethane, yield will be obtained near about 65%, and the product, again this is a SN2 type of the reaction. Once again obtain, it is going to attack on here living group is at beta side, and therefore you are going to get the product the same over here. Here now the nucleophile which is attacked over here according to as a SN2. So here we can show the structures like this. This is a structure we can show as it is. Here oxygen atom, this is a chair form. Now here OBN, other part remains as it is. This azide group, good living group will be there, and this part of this structure number 8, that is a disaccharide, once again we got over here, and now we can write this one O all. These all are the protected group which are lying at at an axial equatorial position, and reason we all know the bulkier group prefer to stay at equatorial position when the structure is in a chair conformation, and we know that chair conformation is a more stable. That's why we have shown like this. Now this is a structure number 10 which we got over here, and this is structure number 10 is nothing but as a disaccharide, right? This is a structure of disaccharide, and now this once again structure number 2 will be here plus. Here plus means addition of that 8 plus that disaccharide which I am going to show over here. So this one disaccharide, this one. Now remember here oxygen atom, then this one. I am going to show this structure once again like this, oxygen, this one, and the structure here you can write OBN protected group, and here OBN at equatorial position, here N PH TH, this is also as a protected, and here again benzylic group OBN, which is also as a protected, which is shown like this, and the rest of the, and at this position here NPH TH we can write, and now at an equatorial position there is a O benzyl group, and here the OH which is kept free for getting desired product, so that desired hydroxyl group is kept free over here, and another one here is a CH2OBN, and this is a structure number 11, structure number 8 and structure number 11 together. The same reagent used here, that is a silver silicate in presence of CH2Cl2 dichloromethane, yield is obtained near about is a 76%, and we will get the trisaccharide here. And trisaccharide, generally the compound which we got over here is this one. There is a OBN. Rest of the thing we can write as it is OAL, then OAC, then OAL, then this is not assigned at all, oxygen atom, and then this oxygen, so we can join over here. This is the oxygen atom, and now we can show this group like this, and after that oxygen here we can show this one oxygen atom over here, and we can show this compound as it is. Look at here again, once again NPHTH, here OBN, and here we can write CH2OBN, and at this position here OBN, here we can write this one OBN, then at this position must be NPHTH, and here is here remember OBN, that is a structure, and this is a structure number 12, and where we will get that alpha and beta is nearly 1, means equivalent, means 50% the product we will get. That is this is a scheme number 4 is represented over here. Scheme number 4 just now we have seen over here. So a more predictable approach to this problem has become possible by one Bockel's recognition that an electron withdrawing acyl substituent at O4 and manosyl donor promote beta selectivity, whereas such a substituent at O3 and O6 reduce it. Highly reactive donor acceptor combination seem exempt from this rule. Silver silicate promoted condensation of the manosyl donor 13 with N octanol afford the beta link monoxide 14 in excellent yield even without an acyl substituent at O4 that is represented in the scheme number 4. I think the scheme number 4 that we will see in the next lecture. Whatever we have seen and all these reactions are taking place according to as a SN2 type of the reaction. These are the some of the prominent point you should remember as far as this stereoselective synthesis of beta monoxide is concerned. We are actually trying to synthesize disaccharide, trisaccharide and polysaccharide with the help of this concept that is beta monoxides. Suppose this is a disaccharide, this will be the trisaccharide. So that way, but these whenever there is a glycosidic bond formation takes place and the approach of that nucleophile or the reaction is occur according to as SN2 type of the reaction, and here mainly the beta mixture of alpha and beta is a possible, but predominantly we are getting as a beta, and so that this is the sum of the prominent point you should remember as far as this point is concerned. I think let us stop today here. Remaining we will see in the next time. Thank you. Have a nice day.